Welcome to Spring LIB.
In this question, we are given this circuit diagram with three capacitors, and we want to find the number of electrons travel through points A, B, C, and D. Given the capacitances of the capacitor, C1 is 4 microfarad, C2 is 8 microfarad, C3 is 12 microfarad. And then we also want to figure out whether the electrons travel up or down through point B and C. Okay, points B and C. Okay, so before we start doing the calculation, okay, there are a few things we can do when the switch is closed. Okay, so when the switch is closed, right? So we can immediately tell that this is going to be a positively charged plate, positive, positive, negative, 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 negative. Here will be negative, and then this will be positive. Okay, right? So yeah, so the side with A is connected to the positive terminal of the battery, so it will be positively charged. And then the left plate of C3 here is going to be negatively charged because it's connected to the negative terminal of the battery. Okay, so to find out the number of electrons that travel through points A, B, C, and D, what we can do first is to redraw the circuit. Okay, so we redraw the circuit. Yeah, by trying to find out what's the total, what's the equivalent capacitance. Okay, so C1 and C2 are in parallel, right? So uh, so the parallel capacitors, the capacitors in parallel, we just need to add up their capacitances. Okay, so we get so C1 and C2, when you add up, you get 12 microfarad, and then in series with C3, 12 microfarad. Okay, this is what we get. Okay, so the 12 microfarad will be in series, and this becomes okay. So just to recall, okay, capacitors in parallel. Okay, CEQ is equal to C1 plus C2, and then capacitors in series, the equivalent capacitance is 1 over C1, 1 over CEQ is 1 over C1 plus 1 over C2. Okay, so you get, so if the capacitances are the same, then you get half of it. Okay, all right, so from this diagram, you can calculate the charge stored in the circuit. Okay, this is equal to C equivalent times the voltage of the battery. So we have 6 microfarad times 12, so we get 72 microcoulomb. Okay, so we expect point A and point D. So if we look at the redrawn circuit, this will be our point A, and then this will be our point D. Okay, yeah, so point A and D will have the same charge, okay, based on the diagram. Okay, and then we can actually calculate the number of electrons. Okay, number of electrons, and the charge is 72 microcoulomb. Okay, so the number of electrons through point A. Okay, this will be Q divided by E. Okay, 72 times 10 to the negative 6 divided by 1.6 times 10 to the negative 19, and you get 4.5 times 10 to the 14. Okay, so this is the answer for point A. Okay, then points B and C. Okay, so one thing we know is that the voltage across this capacitor is 6 volts. Okay, so Q1 will be C1 times 6 volts, Q2 will be C2 times 6 volts, okay, because Q equals to CV, okay. So using Q equals to CV, okay, and then for point B, it will be C1 times 6 volts, okay. V1 equals to V2 equals to 6 volts, okay. So, and charge through point B will be C1 times V, okay. C1 is 4 microfarad, okay, and then V is 6, so you get 24 times 10 to the negative 6 coulomb, okay, and then the number of electrons through point B is equal to QB divided by E, okay, 24 times 10 to the negative 6 divided by 1.6 times 10 to the negative 19. You calculate this, you get 1.5 times 10 to the negative, no, times 10 to the 14. Okay, that will be the number of electrons through point B. Okay, then part C, okay, the formula is still the same. Q equals to CV. Okay, QC, the charge that flows through point C, okay, will be C2 times V. C2 is 8, C2 V2, yeah. Okay, 8 microfarad times 6 volts, you get 48 times 10 to the negative 6 coulomb, and the number of electrons through point C is equal to QC divided by E. You get 48 times 10 to the negative 6 divided by 1.6 times 10 to the negative 19. This is 3 times 10 to the 14 electrons. Okay. And then lastly, not lastly, but part D. Okay. Okay, there are parts E and F. Okay. So point D, we said that this is equal to the number of charges through point A. Okay, so the number of electrons through point D is equal to 4.5 times 10 to the 14 is equal to QB and QC if you look at the circuit diagram. Okay. Okay, then part E. Okay, here I'm just going to redraw the circuit diagram. C2, C1, C3. Okay, when the switch is closed, this is how it looks like. Okay, this is our point A, C, E, and D. Okay, and then just now, I also draw on the charges on the plates. Okay, so based on how the polarity of the plates, right, you can tell that the direction in part E, we want to find the direction of electron through point B. Okay, so the answer is upward. Okay, because you can see that the bottom plate of C1 is negatively charged, so electrons must go there. And then for C2 is the same. The answer is also upward. Okay, because the right plate of C2 is negatively charged. Okay, yeah, this is obvious after you draw the polarity of the plates. Okay, and that's all for this answer question.